Good afternoon, good morning, good evening, depending on where you are on this fast forward planet, wrapped in a pandemic, overheating, as the IPCC climate panel made clear yet again a week or so ago. And and then there are these normal things like hurricane season that have some components related to climate change, but that really are just a fundamental part of how the world works. And Rebecca, I see in the green room. I'll get you in a second. I'm Andy Revkin at the Columbia Climate School Earth Institute, where I run a program in communication, innovation, and impact. And I'm pleased today, on very short notice, to have Adam Sobel, who's a climate scientist, who is really focused more and more on bridging the basic science of climate and of extreme weather, not all of which is related to the jolt we're getting to the system yet, but it's in there. Adam's, I think, what I find is very exciting about Adam's work is he's moved more and more toward what he calls usable science. In other words, how do we get this knowledge we've gleaned on climate change, climate risk into the public sphere in ways that can make a difference. Also, Mary, on extremely short notice, Mary Hegarty and I believe Rebecca Morris, if we can get the tech to work. Here, I'll get Rebecca in here. Yes, there we go. Rebecca, are you also at UC Santa Barbara?
No, I'm at the National Center for Atmospheric Research in Boulder, Colorado.
Great. Okay. Great. So this is a superstar session then. Mm-hmm. And Rebecca, thank you also on short notice for being here. And Mary Hegarty is at UC Santa Barbara, and I noticed just this morning some of the papers you and your group have written specifically about public perception of information like what's on the screen.
Exactly.
And let's start. So we're talking about Henri, and I just want to show you something I always try to track on the NHC NOAA.gov website, which is not just the real-time, the latest observation of a track, but the evolution of tracks over time. So this was Henri. Let's see if we can get this to work. As you can see, we'll talk about this. I'd love to start with Adam, just like what are we seeing? And here, this is day by day, twice a day, the evolution of what computers are telling us about the storm. And you can see right here, some big stuff happens between this initial concept of what the storm might do over 5 days and what has evolved. And the question is, and we'll get to the behavioral components in a minute, on a day-to-day basis, how does the public react to this information? What do we do to make it better? So maybe we'll start with that basic climate science. Adam, can you just give a thumbnail of, your history of looking at storms like this? And I know you wrote a book on Hurricane Sandy, for example, which did a real hard left turn, dramatic change, and that kind of thing is still not out of the possibility here. But what does this say to you when you see what the latest thinking on the storm and how this evolves over days?
Yeah, this is a pretty, we don't get hit by hurricanes very often in the Northeast United States. And that's because the winds here generally blow offshore. They blow from west to east. And so, which is the opposite of how they go in the tropics. So you can see in the beginning of this forecast how it's like moving towards the coast, but then it drifts north, which they typically do. And then as it goes north, they generally get caught up in the prevailing winds, which blow toward the east, and that moves them away from land. So that's the kind of typical situation, and that's why hurricane landfalls here are rare. I mean, they also tend to weaken as they get up here over colder waters, but they can sometimes strengthen as they partly transition to winter type or extratropical storms. So anyway, so that's what usually happens. But then what sometimes happens is something prevents that. So that's what it looked like this at the beginning, that Henri was going to blow offshore, and then the high pressure system to the east of it developed a little more, which started to prevent that eastward drift. And so basically, if you have a high pressure, it's hard for me to do it. I think if I'm looking at the camera, my directions are going to be going the other way. But like, we need the TV weather forecast whiteboard or something.
Whiteboard, right.
But the high pressure system goes clockwise and the low pressure system goes counterclockwise. So if the storm has either high on the right or low on the left, that'll push it up north instead of going east. And that's what kind of almost always has to happen. Either one or both of those things has to happen for the storm to track straight north like it's doing here. And that's what happened in Sandy, and that's what's happening here, and that's what's happened in all the classic Northeast hurricanes. The 1938 one, there was a few in the 50s. They're all like that to one degree or another. Sandy was really extreme because the low that was coming in from the land got in an orbit with Sandy. It's called the Fujiwara Effect, and sort of slingshot it backwards, west onto the shore, and that's why it hit so perpendicularly, which was part of why it was so bad. If you look at the charts for this one and how they're evolving in the forecast models, it is actually quite Sandy-like in broad outline, but the details are different enough that the outcome's probably going to be pretty different. In some of the models, it's making a left turn. In fact, you can even see that here a little bit in the NHC track. It's curving left. In some of the models, it does more so, and those are the ones that bring it to more like Western Long Island instead of Eastern Long Island. There are a few outliers that still bring it into Jersey. I don't think that's likely. It's not what the NHC is predicting, but it's not totally out of the question yet. So because of that, you need to be on the right side of the storm to have a bad storm surge, and so that's why the storm surge was so bad for New York and Sandy. It's probably not going to happen here, but we can't rule it out. The other thing is Sandy was really, really huge. And that made a lot of the effects, but especially the surge and also the power outages, the trees down and such, worse. Henri is not nearly that big. And also the way Sandy interacted with the other low pressure system at the end kind of strengthened it, whereas it doesn't look like that's likely to happen here. And instead, as often as storms come up, when they get up here, they tend to be moving pretty quickly. That's what they need to do to maintain intensity because the water is getting colder. And if they hang out over cold water, they'll weaken. And this one looks like it's going to slow down. You can see the little dots getting closer together. Each one of those is 12 hours apart. So you can see them getting closer and closer together, which means it's slowing down, which is good. Well, it's bad in some ways. It means you're sitting under it for longer, but it also means it's more likely to weaken before landfall. So hopefully this won't be a huge disaster. I think it's extremely unlikely to be a huge disaster for New York City. Even New England, if the intensity is at the low end of the forecast range, hopefully it wouldn't be that bad, but I think we can't rule that out yet. And as I don't know if you mentioned or not, the last hurricane landfall, whether this is a hurricane or a tropical storm at landfall, is going to be close. How much that matters. I would love to hear Rebecca and Mary's take on the messaging there. If you're right on one side or another of a boundary that changes the category, like people might care, but it might not really matter. But either way, the last hurricane to make landfall in New England was 1991, Bob. So it's definitely not frequent. And I think this is it's good that you have experts on who can talk about people's reaction to the messaging.
Yeah, and forecast. That's a great start, and we'll get back to the physics, in a bit. So then we get to this question, which I've dealt with many kinds of hazards: earthquakes, tsunami, hurricanes, and other kinds of extreme flooding, where history is there, but rarity makes it really hard for folks to sustain engagement on what do you do with that knowledge. And maybe we'll just start with Mary, and then get right into Rebecca too. So, Mary, what got someone who's in psychology focused on hazards and response and science? Just give a quick primer on what got you into this mess. It's a hard field. From what I've seen. Let me just preface this by saying I've written the phrase "blah blah blah bang" like at least 20 times in different contexts as a journalist over the years.
So one of my interests is in how people understand visualizations of information, and can we design better visualizations? So if you could go back and put on the slide of that cone of uncertainty up again, I can explain what our research was about. So this is sort of the typical display, I think, that's often on the news. Yours is actually animated, which actually maybe provides more information. But it's the typical display, I think, that the public sees of a hurricane. And there is information at the top about what it shows. It shows the probable path of the storm, but does not show the size of the storm. But I think, it's, first of all, I mean, we know that people have difficulty understanding probability. And I mean, basically what this is, the width of this cone is saying is like, this is the sort of possible sort of range of where, I think it's a confidence interval that says, there's a 66% chance that the path of the cone is going through this area, which means, of course, there's a 33% chance that it would go outside of that. And even, I think either, people don't read this note at the top, or, even if you know this, I think it's really hard. And I mean, even when I was doing this research myself, I kept having to remind myself, this is not the size of the cone. It doesn't, this is not the size of the storm. It doesn't mean that the storm is getting larger or stronger over time, because I think it's just such a natural association we have, right? That, in graphs or anything, larger means more of something, right? And so you really have to, almost, suppress that understanding to understand what this is. But it's also the issue that, probability is in general is just challenging for people to think about.
Right.
So for those reasons, I think what we were trying to do, one thing we tried to do in our research is really, give people more information about what this means, not just the two sentences, but really an explanation. And of what, and then the other so one misconception that people have is that, this shows the storm getting larger or stronger over time. The other misconception they have is that the boundary of the cone here somehow shows the boundary of the storm, which means if you're inside it, you're in danger, and if you're outside it, you're not. So, and of course that's not true, because it is a 66% confidence interval. And also, I mean, the other experts here can let us know, well, even if the center of the storm is going in a particular way, how far could damage, from the storm, how far might you be influenced by that? And then the other type of research we did was compare this visualization to other types of visualizations, just like ensemble visualizations or sort of spaghetti plots, which kind of just show maybe the paths of different models of where the storm might be. And I think those are better. I think it definitely, in terms of people not believing there's a boundary here and you're okay if you're outside it. But there were some misconceptions there too, that they thought, oh, if there's one of these, models happened to go through their town, they were in real danger, but if they didn't, they were okay. So I think those are really the issues. And I think the problem is that we have, the sort of automatic associations that we make, and we really have to suppress those to understand that this is showing probability enough size.
Right. So Rebecca Morris at NCAR, I was just talking about NCAR yesterday on a session here with Mickey Glantz, who was like the lonely social scientist at this supercomputer center looking at climate futures and the like. And we were talking about the Afghanistan drought and issues like that. But it seems that it's vital to have a really dynamic interface between behavioral scientists, social scientists, and folks like Adam to get this better. All this knowledge, the IPCC knowledge, just hurricane understanding, if it doesn't interface effectively, it's kind of hopeless. So yeah, it seems like you're at that interface yourself. Can you talk about this from your perspective? Just give folks a little quick snapshot of what you do there and what you think about when you see a storm like Henri.
Yeah, thanks. So you're right. I worked with Mickey when he was at NCAR, and I am at that interface. So I have a background in atmospheric science. I went to graduate school with Adam. So I have a background in the physics and all of those kinds of things like him, and especially weather forecast improvements. And then I wanted to try to connect that with usable science. And so for the last 20 years or so, a lot of my work has been on improving communication of information and understanding how people perceive risks and make decisions, working with social and behavioral scientists from all different disciplines: risk communication, psychology, sociology, anthropology, geography, all kinds of things. So we do a lot of studies of how people interpret different kinds of weather and climate risks, including hurricanes, tornadoes, and so on. And so I've been studying hurricanes, and specifically for about 15 years, and a number of hurricanes. Interestingly, we have a survey in the field yesterday night, we started a survey of people along the Northeast coast asking how they perceive the risk of Henri. We are getting that data in a couple of hours and we can look at it. And then we have another survey going in the field tomorrow, so we can look at how people are responding to the changing forecast information and what people think the storm's going to do. What do they misunderstand about different aspects of the risk? So this is a new methodology that we have just started using to try to understand in real time how people are responding to forecast information.
That's really valuable work.
Yeah, thanks. It's exciting but difficult to decide whether to field the survey and when to field the survey when the forecasts are so uncertain. We made the decision yesterday morning and it was unclear then, and now we realize we made the right decision. So Adam talked a little bit about the forecast and you showed those. And I think in terms of the forecast uncertainty at different timeframes, the current situation is pretty typical. In terms of, say, 4 or 5 days out, there's still a fair amount of uncertainty about where the storm's going to go. And that's really closely interconnected with the impacts. But 4 or 5 days, often even 3 days in advance, it's really hard to predict which areas are going to experience storm surge or strong winds. You can see that there's a broad swath of the coast that's at risk, where people should pay attention and maybe start making preparations or thinking about it. So that forecast uncertainty intersects with what people really want to know to make decisions to protect themselves, which is what's going to happen where I am. What are the hazards going to be and the impacts, the winds, the storm surge, rainfall, potential flooding, other things like power outages, disruptions to food supply, healthcare, all those kinds of things. And that's what people want to know, but that's not predictable 4 or 5 days in advance. And then you combine that with the fact that people have all different kinds of ways of interpreting information, lots of different perspectives about hurricanes. So people come from really different starting points. Some people are terrified of hurricanes and will evacuate for anything. Some people, it will take a lot to get them to evacuate. People are getting information from all different kinds of places. They have very different capacities to take different kinds of actions, really different social networks, all those kinds of things that are really complicated as far as the starting point when people are getting all this information about a storm and interpreting it and deciding what to do. So you bring all those together, you have all these complexities. So a lot of what we do is try to study those different things and how they intersect and how they lead to different kinds of outcomes, and where are the points where with improved information or other kinds of things you can intervene and help people make better decisions given their situation. And so a lot of it's about the intersection between what can be predicted at different times and what people need to know, and how do you communicate that information. So when we talk to people who are, say, emergency managers or broadcast meteorologists, where a lot of people get their information, are very skilled at taking something like this and then talking about it in a way that reflects what people need to know. And they can also adapt how they communicate based on the questions they're receiving on social media and phone calls and everything. But they talk about, say, at 4 or 5 days in advance, maybe even 3 days in advance. A lot of it's about paying attention. So as the forecasts get better, you can get updated information and really decide what to do. I think, luckily, as Adam mentioned, for this case, at this point, it doesn't look like a major evacuation scenario. So that's a really complicated situation when you look at something like Hurricane Irma that could affect the entire state of Florida. When you have a large population that needs to evacuate, you need to start making those decisions really early when there's a lot more uncertainty. Whereas other kinds of decisions, people can still get water, food, things that they'll be able to use anyway, prepare for potential power outages, and then pay attention and hopefully get updated information if they're in an area that's at higher risk as the storm approaches, to be able to make other kinds of decisions.
One thing I wasn't thinking about talking about today, but I'm going to bring it up now, is something I was talking with Kerry Emanuel at MIT about a few weeks ago, which is categories. And, he doesn't like category 3, 2, 5. And he debates the utility of thinking about a category 6 in a warming world. He says that England, for example, has a color code like yellow, red, green. I mean, whatever, that he thinks is better because they integrate across risk. In other words, rainfall, wind. And I don't know, Adam, maybe back to you on this. Is that an issue too? As we think, if hurricanes are thought about as a coastal problem, for example, or are people getting enough of that sense of the inland risk in the way we currently communicate?
Well, yeah, that's sort of two questions. I mean, the category system is perpetually debated. It used to be, actually, the Saffir-Simpson scale used to be, till not that long ago, I think it was less than 20 years, that it was a more integrated scale. You rated a storm not just by the winds, but by storm surge and pressure. Not that pressure directly matters for impacts, but that was changed some years ago. I think because a single storm could sort of mismatch in the categories and it was confusing. So now it's just a wind scale, but a lot of people don't like that because some storms can be destructive because of rain or storm surge, and the winds don't look that scary. Sandy was an example. Wasn't, the winds were at the edge, the low end of category 1, but because it was huge and where it was coming, the surge was like much, much worse. And, then there's events that are caused deaths due to flooding. So people think you should have a scale that incorporates all those things, but that has problems too. And my take on my naive non-social scientist take on it is that no single scale is free of problems. And I think the Weather Service has come to understand this, and they're trying to de-emphasize the categories now and warn more. They say warn based on impact. So there is a scale for a storm surge. It's feet above where the tide would otherwise be. Rainfall has, all winds and rainfall all have numbers you can put on them, just the physical units we measure, and they're trying to get those, either the numbers or some qualitative measure of those things across, and that's probably the right way to do it. So I'd be interested to hear, Carrie, who by the way was Rebecca's thesis advisor and also teacher of mine. I don't really quite get why colors versus numbers really. I don't know. I mean, that's a more. I don't understand the psychology of that. To me, it seems just boiling it down to one number, whether it's a color or it's a number, is always going to miss some subtleties. And there's always going to be cases where, I guess the case that worries the experts on this is when you have a storm that doesn't quite cross a threshold that gets the dramatic attention, but yet it's just as bad. And Sandy, again, was an example of this because for technical reasons, it wasn't considered a hurricane at landfall, even though it really kind of was for all practical purposes. But because it wasn't called one of the hurricane warnings, and that messed people up and stuff like that, is going to be prone to happening until and unless we can get people to just understand the actual hazards in the way that they actually are, as opposed to by some other label.
So let's go around here, and maybe Mary and then Rebecca. Mary, have you dug in on this? What's the menu of ways in which a multidimensional risk can be conveyed?
Yeah, I think, as I say, mostly we have looked at, just the misconceptions of the main method, the main visualization, and then we've looked at things like maybe having more fuzzy boundaries, not having a boundary, but having it more, fade. One issue I think about color coding is, just from recent experience in California with color coding of COVID risk, why is purple the worst and red? I think cartographers would say it's better to have one color that maybe just changes in intensity, like maybe
to dark.
Light to dark, so that, and then maybe you could have a really graded thing that would really, so you wouldn't have to have those categories. So that would be one thing I would maybe think might be better, just maybe blue to red or something. If you can show a spaghetti plot, that would sort of, I think, Adam.
Oh, you mean for
even, I think there was one up there a minute ago, just so I just show you what maybe was better for people.
Right. I'll go back to that in a second. Rebecca, what's your thinking, or what are people talking about in this context?
Yeah, so I talked about two questions, as Adam and Mary mentioned, and one is about the scale, and I completely agree with Adam that no scale is perfect. All scales have problems, and it's really just supposed to be a first glance, like, is this bad? And we know from research that people understand who are in areas, people who live in areas where they experienced hurricanes understand what the Saffir-Simpson scale is. They know that 5 is worse than 1, those kinds of things. And so at that level, I work with a colleague who also studies earthquakes, and she says people in the earthquake community say the Richter scale is a very poor predictor of damage, but it gives you just a first level impression. And I think, as I mentioned before, what people really want to know is what's going to happen where they are, those specific localized hazards. And that's much more complicated to predict and much more complicated to communicate. And so how do people say that live in this part of New Jersey compared to this part of New Jersey, compared, where they might experience very different risks? How do they get that information? How are they able to interpret it, given the uncertainties at the lead times where they need to make decisions? So there isn't a perfect scale. And as far as the color scale goes, that's a really interesting question, because it's probably more than 5 years ago now. I went to the UK Met Office, which is where they started the scales of hazards, where their warning system is yellow, orange, and red, although they call one of those amber. But they have that scale, and they wanted some advice from someone who had studied these kinds of issues in the US about that scale. And they talked to me about it and some of the issues and the improvements they were trying to make. I think one thing that I learned right away was that the situation as far as weather warnings in the UK and most of Europe is incredibly different than the US. If you're in the UK or Europe, there's one thing that's happening. If you're in the US and you look at the map of watches and warnings, there's 50, sometimes lots. You can have a snowstorm one place, a hurricane someplace else,
Right.
or someplace else, a wildfire,
Size.
And so if you just had a bunch of oranges, everyone would just look at it and not even know if they were supposed to, stay home, leave. So it's a big country with a lot of extreme weather. I think the other thing in the UK that's interesting is that I gave a presentation there about my work, and I talked about how broadcast meteorologists will cut into TV programming to talk about the weather. And they thought that was the craziest idea ever. Like there is very rarely in the UK weather that is life-threatening where you can't just wait for the evening news. There are situations where they do have to evacuate people, but they're very rare, and they're not usually incredibly time sensitive. And so it's a really different situation than in the US, where you might have a tornado or a fire where you have, a few minutes to get out versus several days. And so it's a very, very different kind of weather situation. The other thing that they talked about, even within that, there's one thing going on at the time at most, it's not that time sensitive, that they had difficulties. They would have a couple of reds a year only. That was, you need to do something. But especially with the yellows, they had a lot of trouble, because yellow could mean two things. It could mean something is likely to happen, but it's not that bad. Or it could mean something bad could happen, but we don't know how likely it is. And those are really, really different. And that was a big issue, especially at 2 or 3 days. And it could mean something's further out, so it's not that urgent yet, or it could mean it's really imminent, but it's not that bad. And so when it was like really bad for a location and we're pretty certain and you should do something, that part was clear. But the rest of it, the colors just didn't convey very well what people should do, and there was confusion in those situations. And I'm sure they've updated their system since then, but I think that there's just no one size fits all simple solution for communicating risk that's going to address everyone's issues. Although, I mean, with the cone, as Mary mentioned, and the Saffir-Simpson scale, one issue is that the systems were not designed to do what they're doing. So the Saffir-Simpson scale was not designed as a hurricane risk communication device for the modern world. And the cone was not designed as a public communication product. And so you have something that then becomes a thing that's widely used, and it wasn't intended for that, and it wasn't designed with those things in mind. So that's where we've been working with, say, the Weather Service. How can you think in the beginning, what are you going to try to do with it? So you can try to design it in a way that doesn't require you to always be retrofitting and correcting issues.
Yeah, I think Adam may have a spaghetti plot of Henri ready, but I wanted to also bring up a more general question, which, well, actually, there are two things that come to mind. One is, we've all talked here in the last few minutes about the importance of the local weather forecaster. In other words, getting information to the most trusted, familiar messenger is perhaps almost as important as the nature of the information itself. Does that make sense, Mary?
Mm-hmm. Yeah, I think so. And also, I mean, I guess on a local level, really, the decision makers have to decide, right? Are we going to evacuate this town or not? And then, there have been cases where they evacuated and didn't need to, and then you end up with pileups on the freeway or whatever. So I think there is sort of this interaction between what's happening on a global scale and what the implications are for a particular location.
So interesting. I want to bring up one more general point, and then we'll get back to this, which is a colleague, a former colleague, Kendra Pierre-Louis, who is was at the New York Times for quite a while as a climate reporter, and now is doing podcasting. She tweeted, was it just yesterday that we had here in the New York area also, we had my phone buzzed before I woke up with a tornado warning. And later that day, I was having conversation, I literally can't remember if it was Wednesday or yesterday, with on the global risk with an IPCC author, and his tornado warning alert buzzed on his phone while he was on the webcast. And Kendra writes here, she was driving in Massachusetts. There was a tornado warning sign on the highway today. I was distinctly not sure what they wanted me to do, which seems to get at the importance of knowing the action as well. I guess that gets at what Mary was saying a minute ago too. But maybe you all want to weigh in on that briefly. That'd be cool. And then we'll show that plot.
Yeah, I'd like to weigh in on that. I mean, I think that's the challenge, especially with something localized like a tornado or a flash flood or a fire. A lot of what you should do really depends on where you are. And so I think the first thing the warning does, I mean, people make jokes about the fact that when there's a tornado warning, everyone goes outside to look, but that is actually can be a good idea because you can see how close a potential storm is. And then people have been talking for a while about how to get more localized information. So the warning goes out over a broad area. And then often, because of the way cell phone alerts are, there's an overspray of the warning, and then everyone tries to figure out what to do. There was a tornado warning at the time to pick up my kids at school yesterday. So everyone was trying to figure out what to do right then. People's phones were going off. And so that's an example, a classic example, right? So I think the complexity of what you should do is really is complicated. Another situation that drove this home to me is we had major flooding, flash flooding, and 3 days of flooding in Colorado, maybe 5 or 6 years ago. And a friend of mine was driving at night when the flooding actually was bad, and there were people that died on roadways. And she was driving at night on a road, and she got an alert on her phone that said, "Seek higher ground," which is what you're supposed to do. That's the classic advice. And then she said, "Well, what am I supposed to do?" I drove to a little hill on the road. And then I thought, what do I do now? Do I sit here? Am I supposed to get out of my car and climb? She it's at night, and there wasn't as good communication then. And I realized it was really complicated. And it really depends on where you are, what the best thing to do is. And so some of these things, when there's a short fuse situation like a tornado is, and we have some research in this area as well, is to help people know what kind of environmental and social cues they should be looking for that can help them figure out what to do in their situation. A hurricane's a little bit different because you have more time to decide, and you usually hopefully you don't see it coming at you. You make the decision before it's the last minute. But we've talked to people who have done that, and that's people who have been in those situations. It's very complicated when the water's rising on you and you're trying to figure out what to do.
Right. And
yeah.
That reminds me too, again, people forget that even with hurricanes, it's water that kills most people. I think that's right, Adam, etc. So here's Adam has shared here we go. Adam, can you describe what we're looking at?
Yeah, this is actually plot as courtesy of a group at NCAR, where Rebecca works, but it is an ensemble track plot. So basically there's different models that run many repeats of the same forecast. In this case, it's one model. It's the American so-called GFS model, run many, many, many times with different representations of what the weather is and what the storm is doing at the very beginning that are all close enough that we can't tell the difference between them, given that we don't measure the weather perfectly. So tiny differences at the beginning, and then they grow with time. That's chaos theory. And so different copies of the same model prediction give different answers. And although this is from one model run many times, at this point, if we were to show all the different models from around the world, it wouldn't look dramatically different. So, and what's being shown is the predicted path of the center of the storm. So again, it doesn't tell you the size, it doesn't tell you where the impacts will be and so on, but it gives you an idea of the range of uncertainty. And this spread, that's what we call it, the sort of width of the envelope of, noodles, it's called the spaghetti plot because it's like spaghetti, gives you an idea of the uncertainty. And another thing about the cone, we were talking about what people don't understand about the cone, and a bunch of things. One that wasn't mentioned that I find even most experts in our field don't understand is that the cone is not a dynamic representation of the uncertainty. So that 2/3 probability of being inside the cone is based on the historical errors over the last 5 years. So in other words, every storm this year at 48 hours lead time will have a cone of the exact same size, even though the real uncertainty, which is reflected in some ways by this, what the forecasters really think the uncertainty is, they're looking at information like this, which is more specific to the situation at hand. And some storms can have a greater uncertainty and some a smaller. And over about the last 24 hours, Henri's short-term uncertainty was unusually large, although it's sort of getting resolved now. But anyway, this gives you an idea. One thing I've been talking about with some people at my institution, including our lab director at the Lamont Doherty Earth Observatory, at my employer and yours, Andy, is what the impacts are going to be at Lamont. There's some facilities that are right on the Hudson River, and the director was asking me, should we evacuate those? Not of people. I mean, people can get out easily, but of stuff that equipment and things that could be flooded. So I have been saying that we're probably not going to have a problem on the Hudson River because all these tracks are to the right of New York Harbor, which means that the winds in the harbor will probably be blowing offshore, and so the surge will be away from the Hudson instead of into it. So the Hudson River surge is probably not going to be a problem, but as you can see, it's not 100%. It's like a few of these guys kind of lean just to the west of the harbor, and that was a little more true yesterday. So,
are you able? By the way, can you zoom in a little bit? Can you sort of use your?
Can I zoom in? Oh, I see. Let's see if I can.
Yeah, there you go. Yeah.
Yep. So can you see it a bit better? So you can see there's a couple of these guys that are going just into Jersey, and we can't. The NHC forecasts don't talk about impacts to New Jersey or New York City Metro because they're probably not going to happen in a big way. But if you look at this, you would say it's not 100% out of the question. So if you're talking to your boss who needs to make a decision, on the Hudson River right now, I sort of want to tell her don't worry about it, but instead I have to say probably don't worry about it. But give me another day to watch information. Anyway, so this is what a lot of people look at, and it's interesting. I'd like to hear Mary's and Rebecca's take on this. The Weather Service and the National Hurricane Center do not show these plots. They don't show spaghetti plots. TV forecasters do. Tons of people on the internet do. But I talked to the lead forecaster about this 5 years ago, and I said, why don't you guys show it? Because people don't understand the cone. And he said, well, people don't understand spaghetti plots either. And we know they're going to see it anyway, but we don't want it to come from us because it's just we have to be the solid, voice that uses tried and true. So I don't know. I find these to be more clear in explaining the uncertainties to non-experts than the cone is in some ways, but I apparently disagree with Weather Service on that. So I'm curious to hear the social science perspective.
Yeah, I mean, I'd almost maybe want to show both, but I think both need explanation, so I think you need to explain to people what they're seeing, and, I think these are possible places where it could go. So you can just sort of see the range. Now let's show you on average what we're predicting or something. I don't know. But we did find that, in one of our studies that this, definitely reduce some of the misconceptions, especially the one that the boundary misconception, and obviously it doesn't have that it doesn't. It also looking at this, people don't know that they don't think that the storm is getting larger when it's actually more uncertain. So I think it does address those misconceptions. But I think one study that one of my colleagues did, it was now they think that if there's different paths, and if they're in between that, they're safe, and of course that might be, the place where there's a really high probability. I don't know what if
It's so interesting.
Rebecca has looked at this as well.
Yeah, go ahead.
Do you all have a few more minutes? I just want to get a sense of time.
Yeah.
Great. Okay. Yeah, Rebecca.
Yeah, we've talked to, we've looked at people's interpretations of these, as well as talked to broadcast meteorologists and forecasters about what they use to communicate and why, and the hazards of using these different kinds of information. And one thing that they complain about when people use this on the internet is they will be using spaghetti plots that include models that are not believed to be accurate. So then there can be one solution that some of these versions of the spaghetti plots have some models in them that are there for historical purposes that no one really thinks they're models from the 1960s or 1970s that no one thinks is a really plausible solution. And so people will get really concerned about something that a trained forecaster will know isn't going to happen. Also, when I talked to forecasters in the National Weather Service about this several years ago, they talked about how if you're a meteorologist and you do this all the time, you know a lot about the different kinds of models and their biases. Like for this storm, one of the other major models, the ECMWF, the European model, which in the past has tended to be more skillful, is having the storm go further east. And there are reasons why people think that might be less valid in this case because of the way it's been acting, recently, because of what data is going in, because of this situation. And so if you show the models to someone who isn't enough in the details to be able to interpret those, even someone like me who's a meteorologist who doesn't do this all the time, I don't know that much about it. I hear it from other people. And so you can misinterpret the information and think you're either safe when you're not, or start to get really worried. And we don't want people to get too worried when it's not a bad situation, or just kind of shut down because they're so concerned. So there's a lot of different reasons. And one of the forecasters, the Hurricane Center, said to me, this is probably 5 or more years ago, so it might be a little different now, but basically, why should I listen to a model when I've got the hurricane expert who knows more than anything in the world sitting right next to me? Like, I believe them more. And so some of their products are still based on a human's best interpretation, based on their 30 years of hurricane forecasting knowledge about all the models. And then that's some of their reasons for being more conservative about how they represent the track and the uncertainty, because even with the plots are hard enough to interpret as it is, and to have all these caveats like, well, this one, actually, we don't think this is realistic, and this one. So that's their reasoning, although I think that there's a middle ground, and the models are more skillful than they were 5 or 10 years ago and can be relied on more.
So many interesting points here. One of them seems to be that final level of interpretation with local knowledge, perhaps integrated as well. Like in the Hudson Valley, there's a HudsonValleyWeather.com, which there's a meteorologist who's he does his best guess looking at the models with his knowledge of what's happened in the Hudson Valley, and he's developed a sort of a trust factor with the community. This is where I live. That creates more stickiness, I think. My wife religiously goes to his website when thinking about when she was in the days when she was commuting to think about whether to commute or not. And so that seems really, again, that engagement, that little the fine tuning, the experience and trust seem really important. There's a question that came in on LinkedIn. Is there a recommended cure for disaster amnesia? Meaning, looking at what we were just saying about Hurricane Bob in 1991 was the last time New England had a direct landfall of a hurricane strength storm. And it's easy to forget, to be complacent. And Mary, that's sort of in your bailiwick too.
Kind of, yeah. I'm not sure I have a good answer, though. I mean, except maybe to, I don't know, present some footage of when that happened before on TV, remind people, maybe, maybe they see their, something that damaged their local community. It might just bring it home to them. This could happen again. So I can.
And that could be something local weather folks could do too. Pull up those images. It does remind me. There's one other thing. Sorry.
I was going to say that's a really interesting question. And I have a close colleague, Julie Demuth, who has studied people's interpretations of past weather experiences. And it's really interesting. She asked people about their most memorable tornado experience, and some of them, it was 70 years old, or it was something their grandparent had told them that happened when they were a kid. So there's something about the stickiness of certain kinds of things. For some people, it's something they experienced themselves. For things, it's something someone else told them about. And so there's different ways, like visual, cues, like videos that can get people's attention. I think the other thing is that people have so many things to worry about that it's not surprising they forget, especially nowadays, but even pre-COVID, especially if you're thinking about how are you going to feed your kids, or how are they getting to school, or, how are you going to keep people healthy? People only have so much room in their brain to worry.
Right.
And so they do forget or not pay attention to things, because if you paid attention to everything that could go wrong any day, you would go crazy. You would never drive a car, or walk outside your house, or sit inside your house. So it's just kind of when is the right time that people need to be, it's good for people to be reminded that this thing can happen here, and it has happened here.
Right, just reminding periodically. That also reminds me of a geographer, Stephen Strader, who he has this methodology for illustrating what he calls the expanding bullseye of risk that we have built in areas. When Florence was headed toward the Carolinas, he on Twitter posted live a map of how different the exposure is now to what it was 50 years ago. And it's like this huge increase in risk because of added exposure of hundreds of thousands of homes where there were none before. And I was asking him whether that's something that could be incorporated into a storm forecast. In other words, just as here's the storm, here's what we know about the intensity, here's what we know about the track. And by the way, there's 10 times more houses here than there were 50 years ago. I don't know if that would help too, but that's for another session. There was a question that came in. William Lloyd Garrison in Facebook says he's asking the climate change question, which of course the Intergovernmental Panel on Climate Change just had its new report come out a week or two ago, kind of telling us a little more of what we already knew, that storms that form will be more likely to be stronger, have more rainfall. And still, it may be that there are fewer hurricanes overall in a heating world later in the century. And I don't know, Adam, obviously, maybe we'll circle with you briefly and Rebecca on your sense of whether there's enough change there to change what people should think about when there's a storm like Henri, or where they might choose to live in the future. What do we know more? What's the best short characterization of hurricanes in a heating climate?
Yeah, so we're pretty confident that hurricanes are getting stronger and producing more rain. Those changes are not enormous yet. I mean, in terms of overall risk, they're probably less important than the increasing vulnerability on the coast that you talked about. Whether we're getting more or fewer is still pretty low confidence. A lot of the models have said there should be fewer in a warmer world, but some models disagree, and we don't really see it yet. I think individual basins like the Atlantic, there's some really interesting uncertainties. There's been big increases in the Atlantic over the last decades, and the experts are strongly debating the reasons for that. Part of it seems to be the reduction in aerosol cooling over the Atlantic as the Clean Air Act came in the 70s and the 80s. But there's also the climate models have all consistently predicted for years now that in a warmer world, the Pacific will look more permanently like an El Nino than it has in the past, and that should suppress Atlantic hurricanes. But there's now increasing evidence that is wrong, even though the current generation of IPCC models still says it. So if that's true, we may have been under predicting what's going to happen in the Atlantic, but that's still an area of active debate. I think for hurricane risk on the coast, the most clear thing that's making it go up on the hazard side, purely from the physical system, is sea level rise. So anywhere you live on the coast, sea level is rising. So if you're subject to storm surge, that risk is going up gradually year on year, even if the storms don't do anything differently than they did in the past. Overall, yeah, so it's a lot of uncertainty. I think the envelope of things that can happen is increasing. So in some sense, the risk is increasing when you take into account that bigger uncertainty in some sense means bigger risk as far as we know. But compared to some other aspects of the climate system, like heat waves and fires and hydrological droughts, where we're seeing just these year after year awful disasters in some parts of the world that look unlike anything in the past. The changes in hurricanes are not that striking yet, at least, although we're certainly concerned about them. I think the disaster amnesia is a big factor, and I don't know if you want to share it, Andy, but I put a photo. After the hurricanes of 1938 and the 1950s, the Northeast U.S., which affected New York, Long Island, and New England, got hit a bunch of times. The 1950s were really, really bad decade for Northeast hurricanes. The 50s and 60s, the Army Corps of Engineers put up 3 surge barriers, which are basically massive walls with gates in between that can open and close, and boats can go through when they're open, but you close it when there's a barrier. Those are 3 cities where the estuary sort of leads right into downtowns. They all flooded terribly in those storms. And these were built, Stanford, Connecticut, Providence, Rhode Island, and this is the one in New Bedford, Mass, which I had the pleasure of visiting a couple of weeks ago. I hadn't been to that one before. It's the biggest one. So these are there, and I think that I would be willing to bet that most residents of these cities don't even know they're there. I mean, you can go to the waterfront, and you can look right at them, and they're massive, and you can walk out on it. There's nobody stops you. Just like you can't get into the little facility where the Army Corps operate the gate, but you can walk right up to it. And after Sandy happened in New York, we saw tons of stories about the Dutch and the massive Dutch infrastructure, but we have some infrastructure right here, and I think that's kind of fascinating. I mean, I'm a nerd about this stuff, so I make a big habit of going to see these things when I'm in these towns, or passing through. And that's one aspect. I think in the Northeast, the risk has also gone up. What did you call it? The expanding bullseye has happened here too. Sure. Yeah. But we do have had some track record of infrastructure change that has reduced vulnerability in at least these particular spots where it was very high, but I don't think the awareness is there to go with it. And this infrastructure and the reason it's there are almost totally invisible in the media discussion of these things. Anyway, just curiosity.
Yeah, and Mary, this brings to mind one more thing. It relates to California and earthquakes. Again, I've written a ton about earthquakes too. And what Adam's describing there in terms of the Northeast awareness reminds me of when I was writing about the Cascadia risk, the quake that's going to happen in the Pacific Northwest off of Oregon and Seattle and Vancouver. It's got a 300-year return, and it's epic. It will be an epic event. It will generate a devastating tsunami. But it's on a 1 in 300-year cycle-ish, and there's very little earthquake activity in the background. And California has lots of low-level earthquake activity, where in 1930 or 31, the Long Beach earthquake nearly killed a bunch of students when the schools all fell down right after school had ended. And so in California, there's this more organic understanding of risk. And I'm thinking that kind of reminds me of the U.S. East Coast. In terms of hurricanes.
Hurricanes, yeah.
It's like there's a different challenge in a place where, New York City was hit by an epic hurricane in 1823 or so that flooded that whole area that's now Canal Street. But that's a long time in between that and Sandy, et cetera. So I guess I'm saying this seems to be still a grand and urgent challenge here. On these different scales. Is that we're coming toward the end here? So any last thoughts from you and Rebecca would be great.
Yeah, I mean, one of the things I wanted to do was to look at understanding of, say, these visualizations in regions where there are frequent hurricanes versus not, because in Florida probably people know more about this visualization now and they know how to interpret it because they have to do it frequently. But if there hasn't been a hurricane in the Northeast for a while, then the public have probably not been tuning into this, and and then in terms of disasters in California, I mean, the thing that comes to mind for me is fires, because I actually lost my house in a wildfire
right.
10 years ago. And, we all have the drill, right? We know where we're going. We know what hotel we're staying at, and we have to be evacuated. We've been evacuated a couple of times since. So, it's kind of, but so this, when it's a rare event, then, people are just not prepared for it at all. So that is really an issue.
A really good comment just came in from Betsy Rosenberg about this era where we have so much more exposure, and California changing risk landscape with wildfire. There too, the exposure, the expanding bullseye is enormous. People living in woodlands that are high severity fire risk by the hundreds of thousands who weren't there a few decades ago. And we are entering an era of big consequences. And maybe there won't be time for disaster amnesia anymore. Rebecca, did you have a last thought on this? And again, thank you all for jumping on to this with such short notice.
Yeah, thanks for inviting me. It's been a really exciting discussion. I just had 2 points at the end. I mean, one is we've talked a lot about how people can understand or misunderstand information, and are they going to forget there's a disaster, and so on. And I think it's important, as we've talked about, to not just assume things or not just assume based on impressions, but to actually study it. And that's what we've been trying to do. So we think that people misunderstand the Saffir-Simpson scale, for example, and we know some people do, but we really don't know how many. We don't really know how many people. We know there are people who are have never experienced a hurricane and are completely oblivious, but we don't really know what proportion of the population is. And that matters as far as trying to communicate with them. I also think that we talked about this as well, that this is a really complicated problem. I mean, so many of the climate change, all of the problems we face today relate to risks. They're so complicated. They're complicated interactions of the human environment, physical environment, social structures, communication systems, all of those kinds of things, underlying vulnerabilities and population characteristics and structural racism, and all those kinds of things are all intersecting. And so as much as we would like to have a simple solution, like let's make it colors, or let's change the Saffir-Simpson scale, or let's improve the cone, all of those things can be helpful, but there really isn't a simple solution. And so it's like, what are the most important things to do, and what are the suite of things we need to do to improve the situation?
There you go. I want to close by showing you we have come a long way. We have come a long way. It was in 1961 that some guy named Dan Rather was at the Hurricane Forecasting Center, and he said they had a radar screen, and he said, "Oh, can we put that on TV?" And he's the person who said, "Can we lay the map of Texas on it?" Let's see if this works here. And this was 1961 Hurricane Carla, and it was an innovation at the intersection of media, the TV guy, and the climate knowledge. And it was, I think, an underappreciated, really important moment that shows that we have this potential if we get at the intersection, not just between expertise in different fields, but also the media as well. You can make a big difference and think about where we've come since then. So thank you all for being here today. It was really great. Mary Hegarty at UC Santa Barbara, Rebecca Morse at UCAR, NCAR, Adam Sobel at the Columbia Climate School.
Thank you.
And we have an interesting situation the next few days because of Henri's meandering. Every once in a while there's a storm like this, and thanks for being part of this today. As soon as we're done, you can share these links. This will be, again, it's broadcasting on several different media platforms. I appreciate your time.
Okay, thank you very much. It's been
Thanks,
great.
Andy.
Great.